The ocean is an incredible place. Where else can you find solar-powered slugs, tiny crabs with boxing gloves made of anemones, and entire schools of snails that flap translucent wings to move around? My name is Ned, this is The Curious Current, and today we're exploring 4 incredible invertebrate species and the ocean habitats that they call home. We'll also touch on some of the threats they face, such as habitat loss and a changing climate. Let's dive in to learn more. Okay, before we dive in to understand what is threatening these creatures, it's important that we understand exactly what a sea angel is. Now, despite its name, a sea angel is not a fish, it's not a jelly, it's a mollusk, a relative of snails and clams. But where its cousins plod along on a foot, the sea angel has wings. These are actually modified lobes called parapodia, evolved to flap gracefully through open water. Most sea angels are only a few centimeters long, or less than an inch. They're nearly invisible and their bodies are as clear as glass. Inside, as you can see on the screen now, you can glimpse a beating heart and a flickering gut. Their transparency, it's a survival trick. In the vast mid-water ocean, invisibility is the best defense. Seen up close though, they're hauntingly beautiful. Their gelatinous wings pulse slowly, almost hypnotically, giving them that angelic name. In some species, their bodies glow faintly with bioluminescence, like a drifting ember in the dark. But don't let the delicate looks fool you. Sea angels are predators, and their favorite prey is as fragile as they are. Sea angels survive almost entirely by hunting pteropods, also called sea butterflies, tiny snails that float and flutter through the ocean with delicate coiled shells. I actually covered the sea butterflies on a recent video, which you can see linked on the screen now. When a sea angel encounters one, it unfurls a set of hidden buccal cones, tentacle-like structures lined with grasping hooks. I like to imagine a ghost suddenly sprouting claws. With these, the angel snatches the butterfly and drags it into its mouth, where sharp radular teeth scrape it from its shell. This predator-prey relationship is ancient. It's a fragile balance written into the rhythm of polar oceans. Sea butterflies swarm in incredible numbers, feeding fish, birds, whales, and of course, our sea angels. Without these sea butterflies, there can be no sea angels. And that exactly is where things start to unravel. Now, sea butterflies build their shells with aragonite, which is a form of calcium carbonate. But aragonite dissolves easily in acidic water. As humans pump carbon dioxide into the air, the ocean absorbs it. That extra CO2 reacts with seawater, lowering its pH and making it more acidic. The result is a term that you've probably heard before: ocean acidification. It's invisible, but it's deadly to creatures that rely on aragonite. We can already measure the damage. In some parts of the Arctic, sea butterfly shells are literally dissolving in real time. Their fragile spirals become pitted, thinned, riddled with holes. For sea angels, that's like watching their world evaporate. Their one food source is disintegrating. No butterflies means starvation. And without angels, the balance of polar food webs begins to tip. This is the silent cascade of climate change, not just warming seas, but shifting chemistry that pulls at every thread of the web. And make no mistake, climate change is caused by human activity. The more carbon dioxide and other greenhouse gases that we pump into the atmosphere, the more that the ocean and other carbon sinks have to keep up and continue to absorb carbon to manage the equilibrium of the planet. More carbon going into the ocean means more acidification, which means more dissolving, which means more ecological impacts throughout the food web. Now, why do sea angels matter? Well, it's tempting to dismiss them. After all, they're small, delicate, and seemingly insignificant. But in the ocean, size doesn't dictate importance. Sea angels and butterflies together form what's known as a keystone link in marine food webs. Salmon, cod, seabirds, and even whales depend on the swarms of pteropods for energy. Remember, pteropods are sea butterflies. Without them, predators weaken, and without predators, entire fisheries, the livelihoods of people across the globe, not to mention the food that so many of us depend on, collapse. Sea angels themselves are also indicators. Their presence tells scientists about the health of mid-water ecosystems. If sea angels vanish, it's not just a species disappearing, it's a warning sign for the ocean itself. For all their importance, sea angels remain mysterious. Many live in polar seas, where studying them means braving sub-zero waters and months of darkness. Researchers have discovered dozens of species, each with unique colors, shapes, and hunting styles. Some, like Clione limicina, are found across both the Arctic and Antarctic, surviving in some of the coldest waters on Earth. Others are more localized, adapting to narrow temperature bands that make them especially vulnerable to warming. Even their reproduction seems fantastical. Some species are hermaphroditic, exchanging spermatophores in mid-swim, their gelatinous bodies glowing as they twine together. They're creatures of myth hiding in plain sight, and we've barely scratched the surface of their biology, which makes their looming disappearance all the more devastating. So here's the twist. We almost never see sea angels. Divers rarely encounter them. They don't wash up on beaches. Most of us will live our whole lives without glimpsing one in the wild. And yet, our daily choices ripple into their world. The car ride to work, the plane trip, the factory smokestack, and of course, let's not let corporations off easily. Most of the greenhouse gases being pumped into the environment are the result of corporate activity. Now, all of it adds up to the CO2 that drifts into the sea, tipping the balance of chemistry that has existed for millions of years. The tragedy of the sea angel is that we are erasing beauty we haven't even learned to appreciate. So picture it again, the black waters of the Arctic night. A delicate phantom, wings outstretched, beating slowly against the void. An angel, not of heaven, but of the sea. It drifts, fragile and beautiful, caught in forces it cannot fight. Its fate, like so many of the creatures of the deep, rests in our hands. Thank you so much for watching. My name is Ned, and this is The Curious Current. If you liked the video, please consider liking it, subscribing, and letting me know in the comments what you'd like to learn about next. I'm always interested in hearing from you. Stay curious and stay current. What if I told you that there is a sea creature that eats sunlight? It's not a coral, it's not a plant, it's a sea slug. Well, meet the leaf sheep sea slug, a tiny creature that has a superpower. It has the ability to photosynthesize, and almost no other animals on the planet have this capability. I'm Ned, this is The Curious Current, and let's dive in to learn more. The leaf sheep's favorite food is algae. Soft green strands swaying in the shallows. But unlike other grazers, the leaf sheep doesn't just eat algae and move on. Instead, it performs a little act of biological piracy. Inside every algal cell are chloroplasts, the tiny green factories that capture sunlight and turn it into energy. Most animals that eat algae digest them away. The leaf sheep, it steals them. It carefully extracts those chloroplasts and stores them inside its own body, tucking them into the leafy fronds along its back. We'll talk more about those in a second. But this process is called kleptoplasty, literally stealing plastids. Imagine ripping the solar panels off your neighbor's roof and wiring them into your own house, and then they just keep working. That's what the leaf sheep does. Those chloroplasts keep photosynthesizing, capturing light, making sugars. Now for the slug instead of the algae. Scientists still debate exactly how much energy the leaf sheep gets this way. Some think it's just a survival backup, a kind of emergency ration if food runs out. Others suspect it's more significant, maybe letting the slug stretch out its meals by supplementing with sunlight. Either way, it's one of the only animals on the planet that can borrow the power of photosynthesis. It's part sheep, part plant, and completely a thief. Now, even if it didn't hijack solar power, this little creature would still be unforgettable. The leaf sheep is barely the size of a grain of rice, just a few millimeters long, or much less than an inch. But it looks like something that wandered out of an animator's sketchbook. I mean, I have been a fan of Pokemon my entire life, and this definitely looks like a Pokemon to me. It has two beady black eyes that make it look almost expressive, paired with a set of rhinophores. These are tentacle-like sensory organs that look suspiciously like sheep's ears. That's where the sheep part of the name comes in. Then there are the fronds, which we mentioned earlier. Covering its back are dozens of tiny leaf-shaped extensions called serrata. The cerata are where those stolen chloroplasts live, which is why they glow green like fresh sprouts. But they also make the slug look like a miniature plant, a little succulent with a face. The result is a creature that looks both familiar and alien. Like I said earlier, people very often compare this animal to a Pokemon because it has that whimsical, almost too cute to be real quality. And yet, there it is, crawling across the blades of seagrass, its tiny body shimmering in the sunlight as though it really were half plant. Now, here's the catch. And this being a Curious Current video, of course, there's a catch. For all its cuteness and clever biology, the leaf sheep lives a very fragile life. It makes its home in shallow coastal waters around Japan, the Philippines, and parts of Indonesia, places where seagrass beds and algae thrive. But those habitats are disappearing fast. Pollution and dredging can wipe out entire meadows of algae. Climate change is warming and acidifying these waters, stressing the very ecosystems that the leaf sheep depends on. And because the slug is so tiny, so specialized, it has almost no defenses. If the algae go, the slug goes. It's a reminder that even the ocean's smallest wonders are tied into a much bigger story. A story where protecting habitats means protecting creatures we've only just begun to understand. Now, the leaf sheep is more than an internet favorite or a living cartoon, though it is those things too. It's proof that evolution never runs out of surprises. I think that this species was just discovered in the last several decades. It's a rice-sized slug that dresses like a plant, steals solar panels, and survives on sunlight. Cute, clever, and fragile. An animal that challenges our very ideas of what it means to be alive. The sea butterfly is one such example of an animal covered in very delicate armor that is now subject to dissolving through ocean acidification. If this interests you, make sure that you subscribe and like and let me know what you'd like to learn about next. This is the Curious Current, and let's jump in. Some of the ocean's most fragile defenders are also its most enchanting, the sea butterflies. Sea butterflies, or pteropods, are tiny snails that drift through the open ocean. Instead of crawling on the seafloor, they flap wing-like feet, fluttering through the water column like ghosts of glass. Their shells are exquisitely thin, almost transparent, delicate enough to catch the light like crystal ornaments. For millions of years, the fragile armor was enough. A tiny, thin shell of calcium carbonate kept them safe from small predators, while their drifting lifestyle made them a vital food source for countless others. From salmon to seabirds, from plankton feeders to whales, entire food webs depend on these tiny creatures. But today, their armor is under siege. As humans pump carbon dioxide into the atmosphere, much of it is absorbed by the ocean. There, it reacts with seawater, lowering its pH, making the water more acidic. And acidic water dissolves calcium carbonate, the very mineral these delicate shells are built from. In laboratory experiments, scientists have placed sea butterflies in water conditions predicted for the coming decades. Within hours, their shells began to pit, weaken, and dissolve. Imagine living inside a suit of armor that starts melting around you while you're still inside. That's the reality these animals face. It's not just about one small snail. Pteropods are a keystone species. They are fuel for salmon runs, sustenance for seabirds, and a crucial link for whales and other marine giants. If their armor dissolves, the collapse echoes upward, through the food chain, and into the ecosystems humans also rely on. For centuries, their fragile shells have carried them through ice ages, warming periods, and natural cycles of change. But the pace of acidification today is faster than anything their kind has faced in 50 million years. The sea butterfly is more than just a drifting snail. It is a warning, a symbol of how even the tiniest, most delicate creatures can hold the weight of entire ecosystems on their translucent shoulders. If their armor melts away, what else will follow? The sea butterflies remind us that no design, no matter how ingenious, can withstand rapid change. The ocean has always been Earth's greatest laboratory. It has solved problems we are only beginning to ask, and now it's asking us for something in return. I've always been fascinated by crabs. There's so many different species, they're all beautiful, and there's just so many ways for a crab to be a crab. This has got to be one of my very favorites though. The Pom-Pom Crab, as the name might describe, has figured out how a way to basically incorporate anemones onto its claws as part of its defensive strategy. But there are other purposes to these anemones as well, and today we're going to be unpacking all of the ways that this animal is incredible. So stick around, we'll be jumping into this now. If you had no claws sharp enough to fight, if you were smaller than a poker chip, and if nearly everything in the ocean wanted to eat you, how would you survive? Well, for the pom-pom crab, the answer is quite simple. You bring your own weapons. These tiny crabs carry living sea anemones in their claws, waving them like cheerleader pom-poms. But these aren't for show. They're venomous, stinging pom-poms, and this partnership is one of the ocean's strangest survival strategies. Pom-pom crabs, also called boxer crabs, live across tropical reefs in the Indo-Pacific. They're tiny, usually less than an inch wide, and hide in rocky crevices or coral rubble during the day. But despite their size, they've become masters of defense by forming an unusual alliance. In each claw, they hold a small sea anemone, an animal related to a jellyfish, and these anemones deliver powerful stings to would-be predators. By waving them around, the crab turns itself into a walking, living weapon. This is one of the coolest examples of symbiosis in the ocean, if you ask me. The crab gets protection. Predators think twice before attacking something wielding venomous stingers. But the anemones benefit too. Living in the crab's claws means constant travel across the reef, access to food scraps, and a front row seat to anything the crab captures. It's a win-win. And pom-pom crabs are committed to this partnership. If they lose an anemone, they'll literally rip the remaining one in half. Within days, the clone regenerates into 2 functioning anemones, one for each claw. Watching a pom-pom crab is mesmerizing. When threatened, they raise their claws and wave the anemones like warning flags. In confrontations with other crabs, they spar like tiny gladiators, lunging and jabbing with their venomous pom-poms. But these pom-poms aren't just for defense. Crabs use them while hunting, sweeping their stinging anemones across sand and coral to flush out tiny prey. It's both a weapon and a tool, part spear, part vacuum. Despite their boxing gloves, pom-pom crabs don't rely on fighting alone. They're experts at camouflage, often hiding in rocky cracks or blending into coral rubble until the danger passes. Researchers have noticed that different crabs seem to have distinct personalities. Some are bold, waving their pom-poms constantly like they're showing off, while others are cautious, keeping their weapons tucked close until they need them. This mix of strategies makes them surprisingly successful for something so small and fragile. The pom-pom crab's alliance with anemones highlights something bigger. Cooperation shapes survival. By teaming up, both species thrive in an environment filled with predators. The crab gains protection, the anemones gain mobility and food, and together they succeed where they might otherwise fail. This isn't unique to pom-poms. The ocean is full of unexpected alliances, from cleaner fish and reef sharks to coral and symbiotic algae. But few partnerships are as visible and entertaining as a crab waving living, stinging pom-poms that are made of anemones. So for me, pom-pom crabs are a reminder that survival doesn't always mean strength. Sometimes it means creativity. Sometimes it just means finding the right partner. And sometimes it just means carrying your friends around like tiny venomous boxing gloves. The ocean is full of strange solutions to impossible problems, and the pom-pom crab is one of the most ingenious examples we've ever discovered. Thanks so much for watching. This is Ned, the Curious Current, reminding you to always stay curious and stay current. If you enjoyed this video, please consider liking, subscribing, and leaving a comment letting me know what you'd like to learn about next. I'm always interested in hearing from you.